Okay, we've already talked about roots of polynomials, so now we're going to talk about multiplicity of those roots. So here's a polynomial. F of x equals x plus 1 squared times x cubed times x plus 2. So this is a degree 2 plus 3 plus 1 polynomial, which is degree 6. Okay? Now we have three roots. We have roots at x equals -1, x equals 0, and x equals -2. Now for each of these roots we have a multiplicity. So for x equals -1, that's this factor. We're going to look at the degree of this factor, and that's going to determine our multiplicity. So this is going to have multiplicity when x equals 0, that's when that term is equal to 0. The degree of that term is 3, so this has multiplicity 3. And then at -2, that's when this term is equal to 0, and that term is of degree 1, so this is this has multiplicity 1. So now let's go and look at what multiplicity tells us about how the graph behaves. So here's the graph of our polynomial. We have three roots, -2, -1, and 0. -2 has multiplicity 1, -1 has multiplicity 2, and 0 has multiplicity 3. And what we can see is that sometimes we pass through the axis, like at -2 and 0, at the root. And other times we just touch it and then we come back down, right? And what that has to do with is whether our multiplicity is even or odd. So here's the graph of y equals x squared. This has a root at 0, and that root has multiplicity 2. And at 0, we just touch the axis. We don't go through it. Now, if instead our graph was y equals x cubed, then we still have a root at 0, but now we're passing through it. That's because our multiplicity is now 3. 3 is odd, so we pass through the axis. And 2 is even. That's why we only touched it. So just one more example. X minus 2 to the 5th, x plus 3 to the 8th. It has -3 as a root, and that root has multiplicity 8. So we're touching the axis, but we're not passing through it over here. And then x minus 2 gives us a root of 2. It has multiplicity 5. So that's why we're passing through the axis at +2.